Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have m plus n equals to 3 and mn is equals to 6, and we solve this problem for all the values of m and n. So first we call this is our equation number 1, and we will be called that this is our equation number 2. So we need to solve both of these two equations and we get the values of m and n. And now we move towards the solution of this problem. Here our equation number 1 is implies that from here we move the term m from left hand side to the right hand side, and we will get our n is equals to 3 minus m, and we called that this is our equation number 3. So we substitute this value of n into the equation number 2. So our equation number 2 is implies that this is mn equals to 6, and we have the value of n is 3 minus m is equals to 6. And now further in the next step we multiply this value of n m on both of these two terms, and it will becomes here 3m minus m times of m becomes m square, and this is equals to 6. And further in the next step we need to move the values from left hand side to the right hand side, when we move these two values to the right hand side, it will be written as this is minus m square. When we move it into the right hand side, it will becomes plus m square. This is plus 3m becomes minus 3m, and this is plus 6, and this whole equation is equals to 0. And after little bit simplification, you see here we get our equation into the quadratic form of m variable, and here we use the nice quadratic formula to solve this quadratic equation. Now for this we need to write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 3, and c equals to 6. And we state the quadratic formula as m equals to minus b plus minus square root of b squared minus 4 times of ac divided by 2 times of a. So here when we substitute both of these two values in this equation, it will be written as m equals to minus b. The value of b is minus 3 plus minus square root of b square. B is minus 3 square minus 4 times of a is 1, and c is 6, and it is divided by 2 times of a, and here our a is equals to 1. And further in the next step we need more simplifications, and we get here our m is equals to this is minus times minus becomes plus 3, and plus minus square root of minus 3 square, and minus 3 square becomes 9 minus this is 4 times of 6 becomes here 24, and it is divided by 2 times of 1 is equals to 2. And here we need to subtract these two values, and we get here 3 plus minus square root of 9 minus 24 is equals to minus 15, and it is divided by 2. So here you see that negative sign appears inside the square root sign, and we very well know about that. This will becomes here iota, and we get 3 plus minus square root of 15 times of iota, and it is divided by 2. So these are the two values of m, and now further in the next step we need to find the corresponding values of n. So for this we first copy down equation number 3 here, so that our equation number 3 is implies that n is equals to 3 minus m, and in this side we use the positive value of m. It is 3 plus square root of 15 iota, and it is divided by 2. And in this side we use the negative value. It is 3 minus square root of 15 iota, and it is divided by 2. And further in the next step we use both of these two values in this equation, and we get the corresponding values of n. So when you use this value here, it will become 3 minus 3 plus square root of 15 iota, and it is divided by 2. So here further we need to take the LCM of this term, and when we take its LCM it becomes 2, and we get 2 times 3 becomes 6, and we multiply this negative sign on both of these two values, and we get minus 3 minus square root of 15 iota. Further, we have n is equals to 6 minus 3 becomes 3 minus square root of 15 iota, and it is divided by 2. So this is the value of n which we get here in this method, and corresponding value of m is this one. In the same pattern, we need to find the other values of m, and from this case, when you use this value here, we get n is equals to 3 minus m. The value of m in this case is 3 minus square root of 15 iota, and it is divided by 2. And in the next step, we have n is equals to, we need to take the LCM of this term, and we get 2 times 3 becomes 6 minus, we multiply negative sign on both of these two values, and we get minus 3 plus square root of 15 iota. After little bit simplification, we get here n is equals to 3 plus square root of 15 iota, and it is divided by 2. So this is the value of n. Corresponding to the value of m is this one. So finally, we have, there are two pairs of solutions or two pairs of roots of this equation, and these two pairs are, the first pair of root is 3 plus square root of 15 iota divided by 2, and 3 minus square root of 15 iota divided by 2, and the second pair of root is 3 minus square root of 15 iota divided by 2, and 3 plus square root of 15 iota is divided by 2. These are the two pairs of root, and now in the next step we need to verify that is both of these two roots with a solution or extraneous root. So here we verify these roots, but here in the next step I can just verify the one root from both of these two, and I can left the other root by yourself. So here I can just verify this root, and you can do this for yourself. So now for verification of this, we need to copy down given question statements here, and we have, there are two equations in which the first equation is m plus n equals to 3, and the second equation is m n equals to 6. So from here we have the value of m is 3 plus square root of 15 iota divided by 2, and the value of n is 3 minus square root of 15 iota divided by 2. So we have, these are the two values of m and n, and further we use both of these two values to the above equation, and it will be written as in this form. When we use both of these two values here, it will becomes 3 plus square root of 15 iota divided by 2, and plus 3 minus square root of 15 iota is also divided by 2, and this is equals to 3. So here first we need to simplify these terms, and here we need to take the LCM of this term, and its LCM becomes 2, and we get this is 3 plus square root of 15 iota plus 3 minus square root of 15 iota, and we check that is this equals to 3 or not. You see that this is minus term and positive term are gone, and we get 3 plus 3 becomes 6 over 2 is equals to 3, and this is 2 times 3 becomes 6, and we easily get here 3 is equals to 3. So this satisfies the first equation. In the same pattern we verify the second equation, and we use both of these two values here, and it will becomes 3 plus square root of 15 iota divided by 2 into 3 minus square root of 15 iota divided by 2, and we check that is this equals to 6 or not. So here we use the algebraic formula, and we get 3 square minus 15 times of iota square divided by 4 equals to 6 or not, and 3 square becomes 9, and iota square becomes minus 1, and this will becomes positive, and it is divided by 4 equals to 6, and 15 plus 9 becomes 24 divided by 4 equals to 6, and we easily get 6 is equals to 6. So this shows that the values of m and n satisfy both of these two equations. In the same pattern you verify the second case. So this means that this is the our final solution of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.